Trig triangles is another method of integrating expressions. You're usually going to want to use this when you have a square root that you want to get rid of, and it'll make integrating a lot easier. So there are 5 steps that you're going to have to do when solving using trig triangles. And the first one is to draw your triangle using the information given to you in the question. Next, you're going to solve for x and dx using the information that you have through your triangle. Then you're going to rewrite the integral using different trigonometric functions. You're going to integrate those functions, and finally you're going to substitute once again x and x's so that your final answer is in the same form as your original question. So let's look at this first step, which is drawing your triangle. There are three basic forms that you're going to see the square roots in, and that's the square root of a squared minus x squared, square root of a squared plus x squared, and the square root of x squared minus a squared. And these different forms have different substitutions that you need to use for them. So basically, these square roots are the formula for the length of a leg or a hypotenuse in a right triangle. And we're going to use that to fill in different values for the legs and hypotenuse. So when we have the square root of some number squared minus another number squared, that is one form of the length of the leg of a right triangle with the hypotenuse of the first number. So right away we can tell that the hypotenuse is going to have length a. Now we also know that the square root of this term is going to be another leg. So one of our legs is going to be x. And finally, well, this is the expression for the length of another leg. So our third leg is simply going to be that expression, a squared minus x squared. And now if we solve for x, which is the second step, we get that x is equal to, to get x, the sine of theta is equal to x over a, so x is equal to a times sine theta. Now let's look at the second form, which is the square root of a squared plus x squared. Well, this is the formula of the length of a hypotenuse of a right triangle, with one leg is a and one leg is x. So right there we can already say that one of our legs is x and the other leg is a. And then our hypotenuse is simply this equation right here. So that's just a squared plus x squared. Now, if we want to solve for x, and when we're solving for x in all of these, we don't want to solve in terms of the square root, because that just makes everything messy again. So if we don't want to use a square root, well, the tangent of theta, that's just going to be opposite over adjacent. So tangent of theta is x over a, which means x is tangent of theta times a. So x is equal to a times the tangent of theta. Now let's look at the third one. Well, once again, this is just like the first one. It's a value squared minus another value squared, so that's the equation of a leg, of the length of a leg of a triangle. And the first value is going to be your hypotenuse, so we already know that x is going to be our hypotenuse, and a is going to be another leg. And then finally, the third leg is just going to be that expression right there. And once again, if we solve for a and we don't want to use this square root, well, cosine of a is just, that's going to be a over x. So if we solve for x, we get that x is equal to a times 1 over cosine, which is secant theta. So take a minute to make sure that you understand how I got all these three. And while these three are common, and you might watch lots of other videos and read other texts online where they say that these are the three equations that you kind of need to memorize for these forms, you don't really need to memorize it, because again, we're just deriving this triangle from what we're given, and then we're solving for x. We could have easily, let's just look at this first triangle, we could have easily, instead of writing x over here, we could have written x over here. So if we would have swapped x here, well then x would have equaled a times cosine theta. So it doesn't have to be this. It's good to memorize these forms, but it's even better to understand how we got these, because sometimes it's going to be useful to write it specifically as a cosine theta rather than a sine theta. So now let's look at a sample problem. So we have the integral of x over the square root of 4 minus x squared dx. So let's just look back at our steps. So the first thing is to draw our triangle. Well, let's see what form this is in. This is in the form of the first one, a squared minus x squared, where a squared is 4. If a squared is 4, that means a is 2. So we can basically just say the same thing that we set up here, which is that our hypotenuse is going to be a. So that's going to be 2. X is going to be one of the legs. And then the third leg is going to be this 4 minus x squared term. So when we're looking at this whole integral, we're just kind of looking only at the square root, because that's what we're trying to get rid of when using this method of integration. So the next step is to solve for x in dx. And if we do that, we can say, well, sine of theta is equal to x over 2, so as x is equal to 2 times sine theta. And now we can solve for dx. Well, if x is 2 sine theta, just take the derivative. And now if we go to the third step, now we need to rewrite the integral. So we want to get rid of these x's and instead have thetas. So let's look at the top. We have an x. Well, we know what x is. X is just 2 sine theta, so let's write that up top. And the bottom is the square root of 4 minus x squared. So we don't want to write that. We want to write that as a trigonometric function. So when we're solving for the square root, that's going to be one of either the leg or the hypotenuse. And we want to use a trigonometric function that replaces this. And when we're finding a trigonometric function, we don't want to use this x. We want to solve it in terms of this constant. Well, we can use the fact that cosine theta is equal to, that's just adjacent over the hypotenuse. So it's just going to be square root of 4 minus x squared over 2. So now we can solve for the square root of 4 minus x squared. And that's just going to be 2 times cosine of theta. So we can go ahead and drop that right here. And this is the part that a lot of students forget. We still have this dx, and that's why we solved for dx, because we can't forget this. We want to integrate in terms of theta, so we have to substitute dx using theta, so we solve for that. So let's put this 2 cosine theta in here. And now what usually happens is a lot of things are going to cancel out and it's going to look nice. So what we're left with is the integral of 2 sine theta. I'm going to take out the constant, so we get 2 times the integral of theta. And then we're done with that third step of rewriting the integral. So now let's do the fourth step, which is to integrate. And this one's easy. Lots of times they get pretty difficult, especially with trig triangles, sorry. So the integral of sine theta is negative cosine theta. So we get 2 times negative cosine theta. And remember, we don't have limits, so don't forget to add c. And now that we did that step, we can go on to our final step, which is to substitute once again. Since our question was in terms of x, we want our answer to also be in terms of x, and currently we have it in terms of theta. Well, we already know what cosine of theta is because we already solved it right over here. Lots of times you're going to have to rederive this, but in our case we already solved it. Cosine theta is square root of 4 minus x squared over 2, and actually we can just go ahead and see that we already solved for 2 cosine theta already. So we can go ahead and plug that right in there. So we have negative 2 cosine theta, that's square root of 4 minus x squared. Don't forget to add c. That's how you do trig triangles.